Hi, folks. In this video, we're going to take a look at two different examples on how to do probability with a tree diagram. Okay, and so we're going to take a look at this first example. It's a standard deck of cards, which has 52 cards in the deck. And of these cards, we have a few different kinds. Okay, we have 12 cards that are face cards. So like the Jack, the Queen, the King. And we have 40 cards that are not face cards, and we'll just call them N for like just regular number cards, okay? And so in this question, we're gonna draw two cards, one at a time. And after we draw the first card, we're actually gonna put it back. So that's what we mean when we say with replacement, okay? So all possible outcomes are shown in the tree diagram as frequencies, like how many times things happen. And we want to use this tree diagram to calculate the probability of FF. And just to be clear, probability of FF really means probability of drawing a face card and another face card, okay? All right, so let's take a look at this tree diagram, okay? So if you think about a tree generally has branches, and so that's what we have going on here. But along each branch, it sort of tells us like how many cards, the frequency of those possible outcomes, okay? Now, I wish they had used maybe more contrasting colors, but this slightly darker yellow / green, that represents the first card that you draw. So you pick a card, and the first time you pick a card, 12 of those cards could be face cards and 40 of them could be number cards. But once you picked it and you've looked at it, you put it back. And then you draw again, a second draw. And this time, if you picked a face card the first time, either you pick a face card again or you pick a number card the second time, okay? Now, if you picked a number card the first time, it's possible that you pick a face card the next time, or a number card the next time, right? Those are sort of our two groups, if you will. And what we see is that because this is a something and something else, we take our two draws and we multiply them to give us the frequency, like how many times this could possibly happen, okay? So the frequency of drawing a face and a face card is 144. A frequency of drawing a face and then a number card is 12 times 40, or 480. Now, if you draw a number card first and then a face card, you really have 480 possibilities of those. And then the most common, or the highest frequency, you draw a number card and then you draw a number card. And 40 times 40 gives us 1,600. Okay. Now I want to calculate the probability. So probability of FF, which means I have to put like the frequency of the FF, which is 144. Okay. So this, meant to do the highlighter there, sorry. This frequency, 144, over the total number of ways that this could happen, okay? To get the total number, we could add all of these together, okay? So 144 plus 480 plus 480 plus 1600 will give us a total of, let me get my calculator, 2704. So 2704. That means the total number of ways that this could happen is 2704. Okay. And so we could just take this and divide it. 144 divided by 2407, and we would get 0.0598. 144, so I typed in the numbers wrong. 144 divided by 2704 should give us 0.05325. So it's a pretty slim chance that we're going to get a face and a face, like about 5%, okay? But another way that we could have gotten this number 2704 is to think about like how many cards that we have in the first one. So 52 cards, we could pick one of those, times, and we're drawing another one, we've put it back, so we still have 52 cards in the second draw. And if you use your calculator, you'll see that 52 times 52 gives you the 2704, okay? And as we move on, we're probably gonna see it more written like this and less like find each one and add them all together, okay? All right, so classic card example, but now let's take a look at a different example, okay? So it says, suppose there were 4 red balls and 3 yellow balls in a box. 2 balls are drawn from the box without replacement. So I'm taking it out, I'm looking at it, but I'm not putting it back into the box. What is the probability that one ball of each coloring is selected? So like maybe I pick a red ball and then a yellow ball, fine. Or maybe I choose a yellow ball and then a red ball, also fine. I just don't want them to be the same color, okay? So in this case, we don't have a tree diagram. So let's use this to practice drawing a tree diagram, okay? So in the first draw, all right, you can either end up with a red ball or a yellow ball, okay? And so this is our first draw. And let's look at the probabilities of each of these as we go, okay? Now, I notice there are 4 red balls and 3 yellow balls, which means there's a total of 7 balls in the box, okay? So that means my probability of choosing a red ball is 4 out of 7. Okay, so how many out of the total? And then my probability of choosing a yellow ball is 3 out of 7. So it's a little bit lower because there's 1 less yellow ball. Now, once we take that ball out, let's think about what other options we have. We could now choose a red one or a yellow one after we've chosen a red one. Or maybe we pick a yellow one first, and then either the next one is red or the next one is yellow, okay? And so these make up the second draw, okay? All right, now keep in mind that in the first draw, we had 7 balls in the box, but in the second draw, we like pulled out one and we didn't put it back. So now there are 6 balls in the box, left in the box, okay? All right, so if I've already picked a red one, that means there's not 4 red ones, but there's only 3 red ones. And now we have 3 out of 6, again, because we have 6 balls in the box at this point, okay? Now, if I choose a red, that means there's still 3 yellow ones in the box. And so I still have a 3 out of 6 chance of getting a yellow ball, okay? All right, so, but what if we picked out one of the 3 yellow ones to begin with? Well, we'd still have 4 red ones out of the 6 balls. So it seems pretty likely we might choose a red one, but if I take out one of the 3 yellow balls, I still have 2 out of 6 balls that are yellow. And so that's how I get that 2 out of 6 probability there, okay? Now, the way these work, we're going to go ahead and multiply down each branch, okay? So I'm going to multiply this red times red to find the probability of choosing a red ball and then another red ball. Okay, so probability of red and red is 4 over 7 times 3 over 6. And fractions, we just multiply them across, so we get 12 over 42. Okay. What about the probability of pulling a red one and then a yellow one? Well, same thing, we're going to multiply, except now we're going to multiply down this branch. All right, so we get 4 over 7 times 3 over 6, which gives us 12 over 42. All right. Next, we want to see what's the probability of choosing a yellow ball and then a red ball. So we're going to multiply down this branch, and probability of yellow and then red is 3 out of 7 times 4 out of 6, which is 12 out of 42. And then last but not least, the probability of yellow and yellow means we'll multiply down this branch, 3 over 7 times 2 over 6. Oh, 2 over 6. And we multiply those and we get 6 out of 42. Okay. Now let's think about this question though, right? We found a lot of probabilities, but let's think about what we want. We want, what is the probability that one ball of each coloring is selected? So in other words, I don't want red, red, and I don't want yellow, yellow. That means I'm going to want only the probability of red, yellow, or yellow, red. I'm going to add those together. Okay, so I take my probabilities, 12 over 42 plus 12 over 42. And I get 24 out of 40. Sorry. 24 over 42. And if I put that into a decimal form, I'll get 0.5714. And so what that means is about 57% is the chance I have of pulling balls that are opposite colors. Okay, so I hope this was useful. I'm going to do one more example that's a little bit longer for probability and tree diagrams. So come on back and check out that video if you still have questions.